then put that on the
What's
okay,
that?
blend that to the school board. They're the one who always want to cancel things. So
That is true. That is true. Maybe I'll bring it up to them next time. Okay, so last week we didn't meet, but I uploaded some videos for Wednesdays and Fridays class. Before we move on, I just want to know, were there any questions about anything that was talked about in the videos from Wednesday's class or Friday's class? Basically solving equations and then graphing lines. Anything about those two sections? If you haven't had a chance to watch those videos, I strongly suggest you do. They're uploaded on the announcements page on our Blackboard. Okay, but if there's no questions, then we can just keep moving forward. Now we're on linear equations review. Basically, we're taking word problems and we're going to graph equations based off of word problems. Nothing really new. It's just extensive a little bit because we're involving word problems. Okay. So if you have the notes in front of you from the chapter on our Blackboard page, we're on page 10. Okay. If you don't have these, you can print these off of our Blackboard page under course materials. So we're not talking about a girl and her lawn mowing business anymore. We're talking about copying machines. Even more boring, I think. But it says a company purchases a copy machine for $32,000. The machine depreciates at $2,000 a year. It says develop an equation for the value of the copy machine. Okay, pretty straightforward. So it says after 4 years, how much is the machine going to be worth? Well, it's 32,000. Oops, let me get this going here. 32,000 minus 2,000 for each year. So this is going to be minus 2,000 times 4. And that'll give us a value of $24,000. Okay. After 8 years, that's going to be 32,000, the original value of the machine, minus $2,000 a year for 8 years. We're basically minusing 2,000 8 times. This is going to be $16,000. So then it says for any value of t, not 4, not 8, but any value, it's just going to be 32,000 minus 2,000 times t. That's going to equal our value. So if I want to rewrite this, make it look a little bit better, it's going to be v equals negative 2,000 t. I'm just putting it in like y equals mx plus b form, plus 32,000. Okay. So then it says find the t intercept. Well, anytime I'm looking for any kind of intercept, you're just going to let the other variable be 0. So if I'm looking for the t intercept, that means let v be 0. So I'm just going to replace the v with 0. I get 0 equals negative 2,000 t plus 32,000. It doesn't matter what you move. I'll add 2,000 t to both sides. So I get 2,000 t equals 32,000. Getting t by itself, I'll divide both sides by 2,000, and I get t equals 16. So if I'm going to write this as a coordinate, it's going to be 16, 0. Because instead of x and y, we're in terms of t and v. What does that mean in terms of the problem? Well, that means that in 16 years' time, the value of the machine will be 0. The machine will be basically worthless. Okay. Now this says find the v-intercept. If I want to find the v-intercept, that's what I get when I let t equals 0. So I'll just plug in 0 for t. I get v equals negative 2,000 times 0. That's just going to go away. So I'm just left with v equals 32,000. So if I write that as a coordinate, that's going to be the coordinate 0, comma 32,000. which makes sense. This is y equals mx plus b. This is my b. That's my y-intercept, or in this case, v-intercept. So that means at time of purchase, the value of the machine was $32,000. Seems a little pricey for a copy machine, if you ask me, but it is what it is. Okay, it says graph the equation using intercepts. I don't know. Oh, your graph got pushed to the next page. Whatever. I'm just going to draw a graph down here. Sorry about that. That's a pain, but let me draw my graph like this. Like that. Okay. So we have our v-axis and our t-axis. So I have to graph these 2 points, 16, 0. Now, this might not be popular amongst other professors, but you can tell them to come talk to me. I don't really care how accurate your graph is. If you're only graphing one line, there's not really any real use for it. So you can kind of just eyeball it. Once we are graphing more than one line, I'll show you how to graph it and what important things you should keep in mind. But for right now, we're graphing the point 16, 0. Where is that? I don't know, right there. We put a color on that. We'll say right here, that's 16, 0. You can label it. That's good enough. I don't care where you put it. Where is 0, 32,000? Well, you could divide this up into thousands or 4,000, whatever. I'm just going to put it right here. That is the point 0, 32,000. And then just connect them. It doesn't really do us any good when we're only graphing one line. What's more important is when we graph more than one line, and we can see how they relate. But for right now, there you go. That's all you need to do. Just put a point anywhere you want. Make sure you label it, and then you're done. Okay. There's the graph. I guess you could use that one if you wanted. Doesn't matter. So then this will involve two equations. So this will be a little bit more interesting about the problem. Okay. So it says two companies, Acme and Emac, offer you very similar sales positions. Acme pays you $25,000 a year, while Emac pays you $10,000 a year plus 10% commission. So it says write an equation for your yearly wages from Acme. So I'm going to call this W with a little a here. That's wages for Acme, a little sub a. For your yearly wages. So your wages are not based on anything if you work for Acme. You're just getting $25,000 every year. That's it. Doesn't depend on commission. So this equation is going to be kind of boring. It's just going to be the wages equals 25,000. That's it. Okay. Now Emac is a little more interesting. Wages for Emac. So that at Emac, I get $10,000 a year plus 10% commission. So 10% of whatever I sell. So 10% is going to be 0.10 or 0.1 times whatever you sell. You can pick any variable you want. Let's just call it C for commission. Doesn't matter. So I'm going to get $10,000 plus 10% of whatever it is that I sell. Any questions on those two equations? Okay. So then it says, where do the lines intersect? This is the same as finding the sales amount when each company pays the same. However, you also have to find the wage. So then this is labeled this point. So I want to know when these two equations are equal. Well, this equation is my wages for Acme. This equation is my wages for Emac. I want to know when those wages are the same. So mathematically, I'm just going to set those wage equations equal to each other. Okay. And then it's just a matter of solving for the variable that's left, solving for C. So I'm going to subtract 10,000 from both sides. So 25,000 minus 10,000. I get 15,000 equals 0.1 C. Solving this equation for C, I'm going to divide both sides by 0.1, divide by 0.1. I get 150,000 equals C. Okay, what does this mean? Well, this means that if whatever I'm selling, let's just pretend it's, I don't know, copy machines still. If I sell $150,000 worth of copy machines at Emac, I'll earn the same as if I worked at Acme. Okay. So then it says, this is the commission. This is how much we have to sell. But it also wants us to find, okay, if I sell that much money, I'm making the same at both companies. How much am I making? Well, it's kind of a stupid question because the first equation is just 25,000. So it's obvious that if I sell $150,000 worth of whatever it is that I sell, I'll make $25,000. If Acme also paid me based on commission, let's just say this was 0.05 C, I'd figure out when they're the same. And then if I want to know how much I'm actually making when they're the same, I'd have to plug it back in, which I'll show you, I think, on the next problem probably. But for right now, since I know Acme pays a flat rate of 25,000, that's how much I'm earning at either company if I sell $150,000 worth of stuff. So there's my intersection point. All right. And now it wants me to graph all of this stuff. Where is the graph? Let's see. Okay, here we go. So I'm just going to start by putting my axes along the left-hand side and the bottom. This is going to be my wage axis, and this is going to be my commission axis. Let's do it this way. It's going to be wages and then commission. So when you're graphing these two lines, there's only 3 points you have to graph. Only 3 points that mean really anything to us. And those points are where the graphs start and where they cross. Okay, so if I'll go back to my equations, if these are written in y equals mx plus b form, I'm going to start at the b, at the number being added. So the w, in this case, the w intercept is going to be this guy. My slope is 0.1. So this means that this is going to start at 0, 10,000. And this is going to start at 0, 25,000. Right? If you look back at the videos from last class, this is going to be a horizontal line. It's y equals something. That was Friday's lecture that I posted. So all I care about is where these 2 points start. So 0, 10,000. Well, where's that going to go? Doesn't really matter. Pick a spot here. There's 0. Put it right here. 0, 10,000. And this is going to be the wages for Emac. Acme starts at 0, 25,000. Well, if this is 10,000, just make the numbers make sense. Make the spacing make sense. This is going to be 10. So this is 20, 25,000 right here. Doesn't have to fall on the lines exactly. You can put them anywhere you want, but just know that wherever 10,000 is, 25,000 is a little bit more than double that. So this is the wages for Acme. This is 0, 25,000. Okay. That's where they start. And I know where they intersect. They intersect at 150,000, 25,000. Okay, well, where's 150,000 on the c-axis? It doesn't matter. Put it right here. Put it wherever you want. It just has to make sense in relation to the other numbers. Here's 150,000. This is so they intersect at 150,000 comma 25,000. Well, here is 25,000. So they have to intersect at the same Y level as that. So there's the intersection point. This is the point 150,000 comma 25,000. And then all you're going to do is just connect the starting points with the intersection point. So this is going to go, it's a horizontal line, just like that, boom. And then we'll do this line. Starts here, intersects there. Perfect. Okay. You can fill in these boxes if you want, but that's the same stuff we just wrote down. Any questions on that? Okay. So then it says, use the equations to determine when Acme pays more than Emac. Remember, Acme's wage equation was a flat rate of 25,000. Emac's equation was 10,000 plus 10% of your commission, 10% commission. I want to know when Acme pays more than Emac. I want to know when Acme is greater than Emac. Okay. I know they're equal when C is 150,000. So my answers are going to be either greater than or less than 150,000. All right. And this, the one extra step you have to remember when you're solving inequalities is if you divide or multiply by a negative, you flip the sign. I don't think it's going to happen here, but if it does, remember, if you multiply or divide by a negative, flip the sign. So here I'll subtract 10,000. I get 15,000 is greater than 10% C. Divide by 0.1, I get 150,000 is greater than C. So Acme pays more. This is kind of weird. I'm going to flip this around. This is the same thing as saying C. Notice its arrow is pointing to C is less than 150,000. This says Acme pays more. I'll write this down. Acme pays more when I sell less, less than $150,000 worth of stuff, we'll just say. So Acme is more if I sell less than $150,000 worth of stuff.
You're missing a 0 on the first 150,000.
Ah, thank you. That's embarrassing right there. Thank you very much. Oh wait, that should be 15,000. That's why I did that. I didn't divide yet. So that's 25,000 minus 10,000. That's where I got the 15,000.
Oh, okay.
So then it says use the graph to determine when Emac pays more. Well, if Acme pays more when I sell less than 150,000, it should be obvious that Emac pays more when C is greater than 150,000. Okay, but it says use the graph. So it wants to know when Emac pays more. Here's the graphs. Take my highlighter. Emac is the red. Basically says for what values of C is the red graph higher than the blue graph? Well, it's for every value after 150,000. They're the same when C is 150,000, but if C is greater than 150,000, the red line is higher, which means Emac is going to pay more. So you can, if you want to write it out, you can say Emac pays more after 150,000. Okay. What are the wage intercepts? Those are the first things we graphed. That is 0, 10,000 and 0, 25,000. And those, in terms of the problem, represent our wages before we sell anything. If you just show up to work and don't do anything, you'll get those respective wages. And it says, what's the slope for each line? Well, the slope for Acme is just a flat rate. There's no X term. So the slope of a horizontal line is 0. The slope for Emac is the coefficient of the C variable, which is 0.1. Okay, and what does it mean in terms of the problem? So we'll say for Acme, your wage never increases. For Emac, your wage goes up 0.1 for every $1 of stuff sold. Okay, kind of a boring example, but the next one will be much, I think, give us much more information. Okay. Let us try this one. Okay, we're going back to the copy machine. So this is a company has a choice of 2 copy machines, one made by Duplicate Company, which charges $32,000 for a new copier. That was the first example we did. This machine depreciates at $2,000 a year. The second company, Multiview, charges $42,000 for a new copier. This machine depreciates at $3,000 a year. The company is interested in determining which copy machine will have the most value after it is bought. For example, the value of the copy machine bought from Duplicate 1 year after purchase is $30,000. 32,000 minus 2,000. So that says write an equation for both copy machines. We already did the first copy machine in example 1. So we'll say the value for Duplicate V sub D is 32,000 minus 2,000 a year. So I'm going to write it like this: negative 2,000. Variable for years, I'll use T, plus 32,000. That's the value of the Duplicate copy machine based on years after purchase. The value for Multiview, that goes down $3,000 years. I mean, negative 3,000 T plus 42,000. Okay. Just stop me if you have any questions at all. So then this says, use the equations to determine where the lines intersect. I want to know when the values of these machines are the same. I want to know when this value equals this value. So that's what we're going to do. When does this value, negative 2,000 T plus 32,000, equal the other value, negative 3,000 T plus 42,000. Just set their value equations equal to each other. And now it's a matter of just solving for T. You really can move anything. I'm going to add 3,000 T to both sides. Too many zeros going on here. So I'm left with negative 2,000 plus 3,000 is 1,000 T plus 32,000 equals 42,000. Getting T by themselves, I'm going to subtract 32,000 from both sides. $1,000T equals 42,000 minus 32,000, which is 10,000. Getting T by itself, divide both sides by 1,000, you get T equals 10. So I only really solved half the problem. I figured out that in 10 years, the machines will have the same value. They'll be worth the same amount of money. But unlike before, I couldn't just say, okay, well, since one's not changing, that's the value they're going to be. No, both of these values are changing depending on the years. So I also have to figure out what is that value that they both have after 10 years. So I know the T coordinate, remember all our coordinates are going to be T, comma, V, years and value. The T coordinate is 10. I also have to figure out, well, what is the value of each machine after 10 years? So I'm going to take that value for T and plug it back into either equation. Since I know the values are the same, which equation I choose shouldn't matter. If you want to just be extra careful, plug it back into both. Make sure you get the same thing. I'm going to plug this back into the first equation. So I have V equals negative 2,000 times 10 plus 32,000. V equals negative 20,000 plus 32,000. So I get V equals 12,000. So I know after 10 years, the machine from duplicate will be the same value as the machine from multi-view. And that value is $12,000. So the intersection point is going to be 10, comma, 12,000. Okay. Any questions on that? All right. So we're going to graph this. Remember, we only need 3 things when we graph it. Oh, this is a big graph. Let me draw my axes. I want that to be black, whatever. Okay, and this one here. So I have my V intercept. This is value. Whoops. And then this is going to be years T. I'm only concerned with 3 points. Let me see if I can zoom out so you can see this whole thing. Nope. Maybe that's good enough. I'm only concerned with 3 points: where they start, both lines, and then where they intersect. So the first one starts at, here's my y-intercept, 32,000. Where is 32,000? Doesn't matter. Put it right here. There's 32,000. This is the value for duplicate. This is 0, comma, 32,000. So the other machines has an initial value of 42,000. Well, now it starts to matter where you put the stuff. If this is 32,000, 42,000 is like another third up. It doesn't really matter. Put it like right there. This is the value of multi-view. This is 0, comma, 42,000. And then they cross. Oh, Haas, you want me to go back 1 page back? Is that okay? Is that what you wanted, Hazim? Joe, that's fine. Yep, that's absolutely fine. You can head out early. Yeah. Yep, no problem. Okay, so now I graphed where they start, 32,000 and 42,000. And I want to graph where they cross, 10, 12,000. Let me actually save this before. Hang on 1 second. Okay. And we are. Okay, good. All right. So I graph where they started. Now I'm gonna graph where they cross, 10, 12,000. So 10, you can actually count to 10 if you want. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's just say that's 10. 10, 12,000. If this is 32,000, 12,000 is going to be a little more than a third of that. So we'll just put it right here. It doesn't matter. It doesn't have to be exact. It just has to make sense with the other two numbers. So this is the point, 10, 12,000. Graph where they start, graph where they cross, and then we just connect, and that's it. You're done. This goes to there, boom. And this goes to there, boom. Okay. So then the next question is going to say, use the equations to determine when the copy machine from duplicate is worth more. Let's not even waste our time with the equations. It wants to know when the copy machine from duplicate is worth more. Duplicate here is the blue line. They're the same, they're equal after 10 years. So the answer to this question is either going to be if it's before 10 years or after 10 years. But when is duplicate more? The blue line is higher after they intersect. The blue line is higher after 10 years. So you can just straight up say, okay, they're equal at 10. The blue line duplicate is worth more after 10 years. Okay. And then it says use the graph to determine when multi-view is worth more. Multi-view is the red line. Red line's higher before 10 years. If you get the answer for D, you better get the answer for E. This is before 10 years. Okay. It says, what are the value intercepts? Well, that's going to be 0, 32,000 and 0, 42,000. And we say that is the initial value of both machines. Machines. There we go. Nope. Machines. There we go. Part G says, what are the year intercepts? Okay. We're not going to do that, but if you wanted to find them, that would be these 2 points, this point here, and this point here. If you're looking for the year intercept, you're just going to let the value be 0. So you'll go back to the initial equations. You'll let the value be 0, solve for t. Let the value be 0, solve for t. I believe you get, this is going to be 16, 0. And this one's going to be 14, 0. Which just means that's how many years until the machines are quote unquote worthless. Okay. And then you can skip the slope question. That's just, it's more of the same. That's the easy stuff. Let's try one. So going to the homework section, let's see if we can do number 1. So it says 2 companies offer you similar sales positions, Mathco and Calco. Mathco will pay you $5,000 a year plus 8% commission, while Calco will pay you $10,000 a year and 4% commission. Careful, 8% does not mean 0.8. 8% is 0.08. 4% is 0.04. So just see if you can come up with answers for A, B, D, and E. So there's no graph paper there. I apologize. So you don't have to graph them, but just try and come up with the answers for A, B, D, and E, and then we'll share out. Okay. And then we'll probably call it a day after that, but give that a fair shot. I'm gonna give you about 3 to 5 minutes. All right, did anyone get an answer for our wage equation for MathCo? You can either type it in the box or just unmute and call it out. Crickets, crickets, crickets.
Hey, I'm still working. Give me a
Okay, I got
moment.
you. I got you. I got you. Yep, take your time. Yeah, I'll give you guys a couple more minutes. No rush. Let me pause my screen again.
For number
Alexis,
one,
not at all. Yeah, I'll go back, Alexis, before I exit out of everything, so you can copy down the first page. Okay, did anyone get an answer for the? Oh, Alexa thinks I'm talking to her again. Hang on 1 second. Let me make this bigger. Okay, equation for math code. Did anyone get an answer?
well, for number one, 5,000 times 0.08 is 400, while 10,000 times
5,000
0.04
plus, right?
plus.
0.08 times commission. Make sure that's plus. 5,000 plus 8% commission. The other one's going to be, let me change this to purple. 10,000 plus 4% commission. So those should be your wage equations. Did anyone figure out where they intersect? All of our coordinates are going to be C, comma, W. The intersection point. Any ideas?
Wait 1 moment. Damn, my eraser's in.
It's a big number. The C coordinate anyway is. Anybody get an answer for the intersection point? Set this thing equal to this thing. See where they cross. This.
125,000.
A perfect. Okay, so they cross when C is 125,000. So that's how much you'll have to make if you want to earn the same amount of money at either company. And then what is that money you earn? Well, you're going to take that answer and plug it back into either equation. So I'll just say, all right, 125,000 times, let's just do the top one, 0.08 plus 5,000. So it looks like you'll earn $15,000 at either job. If you want to check the second one, that's the same thing. We'll do 125,000 times 0.04 plus 10,000. You get the same thing, 15,000. So this is where they're going to intersect. Okay. So D says use the equations to determine when Mathco will pay more. Well, we know they're the same at 125,000. So this is going to be either when C is greater than or less than 125,000. Well, think about it. Here's Mathco. When will it pay more? Notice your starting salary at Mathco is 5,000. Your starting salary at Calco is 10,000. So it looks like if you sell less than $125,000 worth of stuff, Calco is going to pay you more. So when is Mathco going to pay more? When I sell more than $125,000 worth of stuff. So if that's my answer for D, the answer for E is going to be just the opposite. C is less than $125,000. Okay. Any questions on that?
How are you getting the 15,000 for W's coordinate?
So I knew that they were the same when C was 125. So take that 125,000, and plug it back into this C or this C to see what your wage would actually be. So I'm going to do the first one. I do 5,000 plus 0.08 times 125,000. That's where I get the 15,000 from. If I use the second equation, I'll do 10,000 plus 0.04 times 125,000, and I get 15,000 there as well. Okay, so when I solve this equation, I set them equal and solve. That just gave me the C coordinate. You take that value and plug it back in to get the wage coordinate. And it better be the same for both of them. Otherwise, you did something wrong.
How did you get $125,000?
For the coordinate or for D or E? Which one are you asking about?
How do you get the 125,000 in general?
Okay, so that means
Did you-
I'm trying to figure out when or how much I have to sell to make my wages equal. So I'm going to take this wage, which is 5,000 plus 0.08 C, and the other wage coordinate or other wage equation, which is 10,000 plus 0.04 C, and I want to know when these things are equal. You're just setting this equation equal to that equation, and when you solve, that's where I got C equals 125,000. Just like I did here in the last example. Let me scroll back. I set these equations equal to each other to solve for T, where I got to the same after 10 years, plug that value back in to figure out what the actual value after 10 years is. Okay. Any other questions? Okay, so feel free, there's a bunch of examples here in the homework. I think there's like 3 more. Why is it that you have to set them equal to each other? So that's the key. So it wants us to figure out when your wages are the same. So that's why we're setting them equal to each other. So this is my wage for Mathco. This is my wage for Calco. When or what values of C will make this equation the same as that equation. Okay. So yeah, feel free to try and attempt some of the math problems. I think you can do probably the first 2 or 3 sections. Try some of the other homework problems if you like. And then, as always, email me with any questions you have. Are there any final questions? I'm going to go back to the beginning for Alexis. But besides that, any other questions? Okay, well then I will see you all Wednesday morning. Have a wonderful afternoon and stay safe. It's still snowing pretty hard out there, so. Alexis, can you see that okay? Is that too small? Is that what you wanted to see?
Yeah, is there a way that you could zoom in a tiny bit? You're good, thank you.
Rest of you, I will see you on Wednesday.
All right, see ya.
See you later.